Welcome to this academic team. In this video, we're gonna focus on differentiation. Before we solve a question here on differentiation, let's take the definition of differentiation. Please write. Differentiation can be defined as the ratio of change in dependent variable to change in independent variable. The ratio of change in dependent variable to change in independent variable. It can also be defined as the slope of change in dependent variable to change in independent variable. Before we represent this definition in a mathematical way, let's understand the definition perfectly. They said is a ratio. The word ratio here means division. Please take note. Is the ratio of change in dependent variable. Okay, change in dependent variable. The word variable simply means letters. Okay, letter S, letter Y, letter T. Can be any letter at all. Okay. The word dependent, we have to look into dependent later to know what a dependent variable is or what a dependent letter is. Okay. Now the next statement that is very important to us here is change in independent variable. Now we have to know what independent variable is, okay, before we represent the mathematical expression. But we have to know what change in independent variable is. All right. But before then, let's know the mathematical expression of. Before then, let's represent the mathematical expression of this statement here. Mathematically, the mathematical statement of differentiation: change in dependent variable over change in independent variable. Please don't be confused here. The division here is that word ratio. Please take note. Okay. Now, the next we have to do here is to know what a dependent variable is and what an independent variable is. Okay. If I have an expression here, y to be equal to class f of s, this is the definition of a function. Okay. If I have a function or I have an expression or I have equation to be y equal to f of s, of course we have a letter here. The first letter here is y. The second letter here is s. Why the f here represent function. Please take note. The f represent function. The word dependent variable simply means the variable that depends on other. So for me to have the value of y, I need to know the value of s. So s will give us the value of y. Am I correct? So that is not the case here. The case here is the simplest way here to know dependent letter and independent letter is this: the subject letter is always called dependent letter, while the letter that is not the subject is called the independent letter. So our dependent letter here is y. This is dependent. Why we all know that this f here represents function. S is what? Independent variable. Please take note. Y is dependent letter. F is the word f there is a function, while s is independent letter. Please don't be confused here. Whenever you are given equation or a function and you want to identify the dependent later, the subject later is dependent, while the later that is not the subject is an independent variable. So if I have something like this class, I have y is equal to 2p. Of course, we have a letter at the left hand side and we have a letter at the right hand side. And the letter at the left hand side is the subject letter. Remember, subject of formula. While p here is not the subject letter. Okay, so this subject letter here, this guy here, will be called dependent variable, while this guy here will be called independent variable. So this is how we identify dependent variable and independent variable. Now the next thing to know here is how to express the derivative. Now whenever we mention differentiation, the first thing that comes to our mind is dy dx. Differentiation is not always expressed as dy dx. It is always expressed in terms of what is standing as the dependent variable and the later standing as independent variable. Remember, that is change in dependent over change in independent. That word change means d. You can either call change, or you can call it d. Okay, the word change is the same as d. Okay, so if I have something like this, y equal to 2p, how do I represent my derivative? Not to differentiate. To differentiate is different from representing the derivative form. Okay, to represent this derivative form here, this is going to be dy, that is change in dependent, which is this guy here, over dp, that is change in independent. Remember, the d here simply means change. This d here represents change. So the same thing applicable to this. If I have this to be y to be equal to 2x, our derivative will be expressed as dy over dx. Okay, now the same thing here. Okay, if you have something like this, an expression like this, t is equal to 2w, what is going to be the representation of derivative here? Please, I want to get that in the comment section. If I have t is equal to 2w, what is going to be the derivative form? Okay, I want to get that in the comment section. So let's try to solve some questions here in differentiation. Now, before we solve a question here in differentiation, there is something you have to know perfectly. Okay, now why some persons don't know differentiation is because of this. Most persons cannot identify the functions. To differentiate any question at all, the first thing to do is to know the function. Now, different functions have their different formats, or different functions have their different formats. You can differentiate them. Okay, so the format you use to differentiate a particular function might not be the format you use to differentiate other functions. So we have to learn the functions and their pattern of differentiating them. So we have to take the first function here. Please write. Let's take the first function, please. Yeah, the first function here, that is the first one we have to consider here, is monomial function. Okay, all you have to do to get this series is to hit the subscribe button. Please make sure you subscribe. It's free. You don't need to pay. Okay, just hit the button and you get the full series of differentiation. Please, differentiation is very simple. Okay, now let's know what a monomial function is. The word mono there means one. So if I have a function or the equation written in this form here, that is y is equal to as raised to of n. So class, this particular expression here is a monomial function. Why? Because it consists of one digit, a letter, and a power. That is power. Okay, you can call it power, or you call it the normal way is to call it power. Okay, now whenever you have an expression that consists of a digit, letter, and a power, that particular function is known as monomial function. So if I have something written in this form here, y is equal to 3s raised to of 6. Of course, this particular question here is taking the nature of this expression here, or this function here. This particular equation here is taking the nature of this function here, that is a digit, which is 3, letter, and a power. So whenever we have any equation in this function, which is a monomial function, how do we differentiate that? Whenever you have a monomial function or any equation in this nature, we use power rule, that is power law. Now, what is the power law of differentiation? We take the power down to the base, we subtract the power by 1. Okay, take the power down to the base, subtract by 1. I will have this to be dy over ds. Of course, we know why it is dy ds. Change in dependent over change in independent, which is s, will be equal to class. Let's differentiate. Take this power down to the base to be n times, this dot means times, of a of s raised to the power of n minus 1. So class, this is the format we use to differentiate all monomial function. Please take note. You take the power down to the base, subtract the power from 1. So I will have something like this, okay? Now let's solve a question here to apply this particular law. So we are given a question here that is 2021 question 38. All right. They said if y is equal to s raised to the power of minus 3 over 2, then dy ds is, we are given options here. A is minus 2 over 3 of s raised to the power of 1 over 2. Option B is given to us as minus 3 over 2 of s raised to the power of minus 1 over 2. Option C is given to us as minus 2 over 3 of s raised to the power minus 5 over 2. Option D is given to us as minus 3 over 2 of s raised to the power of minus 5 over 2. So let's solve this question here. Solution first. Whenever you are given a question in differentiation, that is whenever you're asked to find dy ds, all right? Now, the first thing to do is to identify the function. Now, we are given a question here, that's a function y is equal to s raised to the power of minus 3 over 2. The word function is the same as the equation, okay? Now, y is equal to s raised to the power minus 3 over 2, and we are asked to find dy ds. So if you look into this particular question here, it looks like monomial function. That is, we have a digit, that is 1 is standing here, a letter, and we also have a power. So to differentiate this here, we use power law. Using power law here, we have this to be dy over ds equal to, you take the power down to the base and subtract 1 from it. This is going to be minus 3 over 2 of s raised to the power of minus 3 over 2 minus 1. Please take note. We have this to be, take the power down here, you have minus 3 over 2 of s, subtract 1 from the power. This is going to be minus 3 over 2 minus 1. Okay, now when you do that, let's simplify this here. Now we have the power to be minus 3 over 2 minus 1. Now if you have something like this in mathematics, that is minus 3, sorry, we have something like this in mathematics, that is 1 over 2 plus 1 over 3. Of course, I will simplify this particular fraction, right? Maybe using LCM or using butterfly method. Using LCM method by finding the LCM and solve, or using butterfly method. And butterfly method is the simplest way. What is butterfly method? You multiply this 3 to this 1 here. You multiply 2, the denominator at the left hand side, to the opposite, which is this guy, and you multiply both denominator. So it's looking like this, something like this to this, just like butterfly. Okay, this to this, and this to this, that is denominator. Okay, just like butterfly. So when you apply that, I will have something like this. For this, 3 times 1 will give us 3. Depending on the sign that is there, it is plus, you put plus, it is minus, put minus, plus. 2 times 1 will give us 2 over 2 times 3 will give us 6. So our answer will be 5 over 6. So you can use butterfly method to solve your fractions. Okay. Now, but we're not giving this here. What we are giving here is minus 3 over 2. This is what we are giving here. Minus 3. We want to simplify the power over 2 minus 1. So making this 1 to be fraction, I'll put over 1 here. Please take note. So let's multiply. Multiply the denominator by your right hand side to the opposite. I will have this to be this. Multiply the denominator at the left hand side to the opposite. I will have this times this. Multiply both denominator, I will have this times this. So it's looking like this. This to this. Please take note. This to this, and this to this. You don't need to do the butterfly this thing. Okay, I'm just trying to show you how it will look like, but you don't need to put the butterfly way. Okay, so the answer here will be 1 times minus 3 will give us minus 3 minus 2 times 1 will give us 2 over 1. 2 times 1 will give us what? 2. So our answer will be equal to minus 5 over 2. Please take note. So I will have this to be equal to minus 3 over 2 of s raised to the power of minus 5 over 2. So class, when you look into the equation is having positive power. So we have to keep the equation in. Sorry, when you look into the equation is having negative power. Okay, so we have the equation to be this. But most times in equation, the equation will always replicate most times the answer will always replicate how the equation is represented. Please take note. So if in the equation the power is positive and the answer is negative, we have to change that power to be positive. Okay, so very simple. All you have to do to get more video on this is to hit the subscribe button. Okay, the option here, the right option here is you can drop it on the comment section.